Alright, ladies and gentlemen, welcome back to Earth Science. We are going to finish the third and final type of rock called sedimentary rock. This rock is my personal favorite. Why? Because it makes up 75% of the world's surface. So we covered first igneous rocks, and then we covered metamorphic rocks. Now we're covering sedimentary rock. Okay, sedimentary rocks, as I mentioned, they're the most common rock on the surface of the Earth. They make up 75%. Arizona is higher because it's mostly sedimentary, by and large. And below are some examples that make that very apparent. Large conglomerate, Papago, and near the Phoenix Zoo, that big old cave up there, that's all conglomerate, which is part of the sedimentary rock. Sedimentary ash layers in Petrified National Forest. You go up on the Navajo Reservation, there's the Painted Deserts. Lots of different types of sedimentary rocks. So sedimentary rocks form when layers of sediment, pieces of eroded rock, get pressed, squeezed, and cemented together. When minerals precipitate out of liquid solution, they can too form a sedimentary rock, like caves, for example, the stalactites and stalagmites. That's what this would be part of. So, for example, you take sediments like this, gravels, you turn it into this, conglomerates. That is a pen for scale to show you the size of these. Okay? So, there are two main processes that form a sedimentary rock. The first one is compaction, and then cementation. Okay? Really important. As shown in this depiction or diagram down here, you have loosely packed gravels get tightly packed due to overburdening pressures, and then the cracks or the spaces called pore spaces between the grains get filled in with groundwater that carries dissolved ions that precipitate out, known as cement. Okay, calcite, quartz, hematite, and others make up limonite, make up that bonding structure to hold these grains together. Okay, you got to compact them first and then fill in the pore spaces, and they become cemented together. I kind of summarized this last 3 sentences. Okay. All right, moving on. Sedimentary rocks form layers. If you were to take a shovel full of dirt and put it into a container and shake it up and let it sit, it will settle out, layer by layer, largest grain down to the smallest grain, creating horizontal layers, like a cake. Okay. So, at the oldest layers are going to be found at the bottom because they were first deposited, and then the youngest is going to be on the top. Don't forget that. That's important to know. Over millions of years, these layers of rock get tilted, cracked, eroded, etc., forming some of the coolest geologic features on the planet. For example, the Grand Canyon, one of the 7 wonders of the world. All it is sedimentary rock, layered, that has been weathered, or eroded away and weathered, leaving behind a grand, spectacular array of sedimentary rock. So, sedimentary rock is pretty much made up of a bunch of stuff, okay? Everything that's eroded, or can be eroded, turns into a sedimentary rock. They can be composed of, important to know, minerals, large and small sediments, and even organic materials, like fossils. Okay? There are 3 types of sedimentary rocks. Within the sedimentary rock classification, there are 3 different types. There's detrital or clastic, same thing, chemical, and organic or biochemical. Those are the same as well. So this is an example of detrital or classic. Classic detrital, that's the group that has the conglomerates, like the gravels, the sands, the silts, and the clays. Okay, that's like your bulk that makes up that group. This one is your organic. So this is it's a sedimentary rock that has fossils in it and buried in limestone. Therefore, it's a class or biochemical or organic. And then the last one is chemical, sedimentary rock. Rock salt is an example of that. Gypsum is an example of that. Calcite is an example of that. Dolomite is an example of that. These are the things that evaporate out of water that were dissolved, like caves or like oceans or lake bodies that dissolve and they leave behind the minerals that it's in the water. Okay. The word clastic, referring to now the first of the three we just discussed, clastic actually means broken into pieces. Detritus means small particles. So put them together, small particles broken into pieces. Perfect. So that's basically what that explains there. Ancient environments, okay, that form these type of sedimentary rocks are as follows: shallow seabeds, sand dunes, river systems, and deltas. Deltas are the mouths of rivers entering into the oceans, where they distribute a lot of their sedimentary rock and grains. These detrital/clastic rocks are classified according to shape and size. Very important to understand. And as geologists, we use primarily 4 different sizes, okay, to help us identify these types of sedimentary rocks. Gravel by that size, sand by this size, silt by this size, and clay by this size. If you need to pause this video so you can record these size measurements, you may do so now. You can tell a lot by understanding the sedimentary rock found with these types. Now, talking about the shape. Now, if the fragments are angular, it means that the rock fell a short distance, possibly like a landslide or a rockfall. It didn't move very far. It didn't weather. If they're rounded sediments, it tells you that the rock has traveled quite a distance, okay? It's rolling around, it's bumping into each other, causing it to weather, creating these smooth stones. Obviously, you find these in river systems. Most rocks that are found in rivers are weathered because they move constantly. Also notice that if you have larger rocks, that means you had a quicker supply, or excuse me, a quicker or more powerful mechanism of moving those sediments, such as water. Flash floods can move large rocks. Slow trickled streams can barely move small silts and clays. Does that make sense? So there's an energy factor that's important to understand in moving them. Okay, the next one is chemical sedimentary rock. They are formed from precipitation and evaporation, as I mentioned. You'll find these when you have minerals that are dissolved into a water solution called an aqueous solution, and when it evaporates, it's left behind, or it leaves behind, minerals. Those minerals, such as rock salt, gypsum, calcite, etc., form these type of rocks. And salt rock, for example, and given here, is when you have ancient seabeds that have dissolved, or the water has precipitated away, or evaporated away, excuse me, and left behind the evaporites, the group of minerals called chemical sedimentary rock. And there's some examples of these here. And last is organic or biochemical sedimentary rocks. They're mainly composed of organic material. When many microscopic organisms die and fall to the bottom of the ocean, their shells and minerals break down and make up what is known now to us as limestone. Coal is another example. Coal is organic matter, basically ancient swamps with all that dead or decaying vegetation that gets settled to the bottom, gets smashed, rotted together, gets compacted down, and eventually is left with carbon, and that is organic matter. And then chert is the last example. Chert is a relatively smooth piece of rock that is formed from microscopic skeletons and organisms, usually formed in deep seas or ancient oceans. However, chert also can be found replacing wood grains, okay, with silica-like minerals that you'd find in the petrified national forest, hence petrified wood. Okay, so basically ancient forests that were rapidly buried due to the landslides or otherwise some activity, geologic activity that caused them to be buried, and then silica seeped into and replaced the wood grains with quartz. So this is an example of petrified wood, example of cave formations, example of coal. All right, your job is to do the following lab now. So now you understand sedimentary rock. This is also found here on this website, also on Google Classroom. They're both located on both locations. Your job is to use, actually, I'm going to give you actually a different lab. This one is the right lab, but it's already all filled out. You just have to identify which one it is. And I give that to class. This is another option, but I filled this all out. You have a dichotomous key will be provided for you, and you will identify the rock name based on the observations, sedimentary size, and the different type of sedimentary rock it is found in with the name. And that will be your job. All right, ladies and gentlemen, get to work. Thanks for everything.